We only have about 4,000 weeks on this planet. And while we build a life in that time that hopefully gets better and better, our health continually declines as we age, no matter what we do. This is something we all know we have to accept. However, there are those fighting against it. While much of traditional medicine focuses on treating the diseases that arise as we age, longevity biotech aims to treat aging itself. The goal is ambitious: to make us live and stay healthy forever. My guest today is Fiona Miller, founder of quadraScope, a longevity venture capital fund. Her fund has an impressive set of advisors, including Aubrey and Barzilai. Fiona has made investments into many exciting startups that treat the hallmarks of aging, and also sits on the board of the Health Longevity Clinic. Prior to entering the biotech industry, Fiona was a successful high-tech entrepreneur with 3 successful exits. She holds 10 patents and is the author of numerous articles, white papers, and test reports on wireless technologies and standards. Fiona has a BA in computer science and BS in electrical engineering from Columbia and did graduate work at MIT. I hope you enjoy this interview. So, what attracted you to the longevity biotech industry?
I haven't been thinking about my own body. I had a full career in high tech, and I was busy, and at one point I became aware that we're not, not going to last forever, and that I'm getting to an age where things are going to start happening to me. And as a good engineer, I decided, well, I'm going to have to be prepared for this eventuality because it's going to happen. And I better start getting ready now while my mind is still working. I didn't get to that age where I'm senile. And I'm going to have to start learning about my body and how it works, because if I don't know, I'm going to be relying on doctors to save me when something bad happens. And we all know about doctors and hospitals. And so I started taking classes. And the more I started learning and preparing for some horrible disease to happen, which I know which one is going to happen, uh, I started realizing, and I came across Aubrey de Grey's lectures online, and I started realizing that maybe it's not as gloom as that. Maybe it is possible to stave off this horrible fate that we all assume we're going to reach. Or some of us just don't think about it, but I wanted to think about it ahead of time. And so it's a lot more inspiring to think about how to extend your health span, and can we really figure out how to turn back the age? Because as you said, it's all about staying biologically young. When we're young, we're healthy and strong, and we have a lot of vitality. We can run for miles, do stuff. When we get older, our joints hurt, our brain becomes foggy, our memory goes. And there are a lot of symptoms of age. It's not one. All the diseases come as you age. And so it makes a lot of sense to say, well, this is the root cause. Aging is the root cause of all these diseases. So from a perspective of a good engineer, okay, let's figure it out. Let's figure out the root cause and how to address that. And that's how I got on this path. When I sold my last company, I now have more time on my hands. The acquiring company took over. They started running the functions I used to be very busy running, and all of a sudden I had more time. And I doubled down on the coursework, on reading, and I couldn't stop. It was just all consuming. It is so tremendously interesting. And there's such depth and complexity to how our bodies work that it is just fascinating. And so I'm still at it. And as I was soul searching, what's the next thing for me, right? So I've done a lot of tech in my life. I've been in tech since the early 1980s, and I need to move on to something else. And this was consuming me. This this topic. And so I decided that I'm probably not going to become a scientist in the lab, with test tube and taking care of mice at my age and the state of my career, but that a good way to apply what I've learned throughout my lifetime is to enable other, younger people, and that's funding companies. I started doing angel investing. That way I could start interacting with the scientists and entrepreneurs who are starting companies. They know what they want to do and why. And through talking, through studying, through reading, I got deeper and deeper into this space.
And you mentioned you were approaching it like an engineer. What's most different in biology from engineering, and what most surprised you?
So they're sciences. They're both sciences. Engineering is applied, and biology can be more of a science in the lab where you're studying certain proteins, you're publishing papers. In the science world, I think there is more emphasis on publishing and collaborating with other scientists. In engineering, you can just be a recluse and lock yourself in the lab and make things that work. And it doesn't mean you don't have to collaborate with others. It's just a little more applied, because you go in there and you tinker on a lab bench and you design and build things more as an engineer.
And you also mentioned, not wanting to go to doctors, issues with our current medical system. I think I even heard you previously mention that you don't really go to doctors. Could you say a bit about that, and I guess what you think is wrong with current medicine?
So actually, I go to doctors, and I try to understand what different disciplines can do and what their limitations are. So I do have a wonderful doctor, primary care physician, and I know she's good because I've seen other doctors, but she's functioning within a system that's limiting her, and not only in the sense of regulatory limitations, which are very big, but she's young and she just came out of school, and whatever she learned in medical school and in the establishment, she's faithfully practicing it. And because I read and I interact with scientists and doctors obviously are different. Doctors learn to practice, they're more like engineers, and scientists are there to figure out the limits and eventually translate into medicine the new science. But she cares, and I understand what the system is, that there's certain practices that they follow, and she's limited, and then there's a whole insurance uh, industry she has to comply with. And I get from them that there are areas where they have wonderful care, and you just need to know what they can and cannot do for you. They cannot do regenerative medicine like what we're trying to do in longevity. But when I got Lyme disease, and being here in Boston, they're the best doctors, and she helped me to get into Dr. Steer, who is a Harvard professor and researcher in Lyme. He's the best in the world, and they cured my case, which was a very complex case of Lyme. So I was very grateful to them. So I'd say take advantage of all these people available to you, but don't just stop there, right? That's the whole idea. But you don't want to depend on them, right? As I get older, they'll just tell you, I would say, well, my joint hurts. And she said, well, you're just getting older. And that's not the answer we want. We want to say, well, but I read this one paper and it looks like they're starting to think about how to fix this or that thing. But your doctor may not know about this paper. So unless you go out there and you can read the papers, interact with scientists, get all these pitches from these new startups that are each thinking in its own area of expertise, that is a powerful way to plug in to a lot of different patterns of thinking, areas, directions.
And what most convinced you that we don't need to take aging for granted, that there actually is something we can do about it, and that it's also a space worth investing into?
Well, I'm an engineer, right? I started learning about it. Um, Basically, Aubrey de Grey came at it from a different, unique perspective. And he said, don't try to fix how your body operates. Don't try to fix the metabolism. Metabolism wears out naturally. It's kind of like a car. When you run the engine, you crank your starter every day, your battery is going to wear out, your starter motor is going to wear out. Think about replacing it. So we have these cars that we can keep running for hundreds of years. We have 100-year-old cars. Uh, but we know a lot less about our body. And so this idea of, yeah, things are going to break down. Maybe there is a way to fix, your organs, your immune system, what is the root cause? And let's start trying to understand what breaks down and how to fix it. And he laid out a foundation on it. Other scientists picked up on it. We've been working at it. Very bright mind, the brightest minds in biology, biochemistry, have been working on it since the turn of the century. Aubrey wrote his first paper and published it in 2002. This paper was published by his Sense Foundation, and he laid out 7 causes of aging, 7 things that go wrong that we can fix, and also how we fix them. And that was the foundation of the hallmarks of aging. We now have 12 of them. They're missing a very important one that actually Aubrey had, which is extracellular matrix. But we're going to come around. There are scientists working on various aspects of aging today.
Do you think we're going to discover at some point a more integrating factor across these, whether it's 7 or 12 drivers of aging? Do you think there's like one root cause we're going to be able to identify and treat, or do you think it really is multifaceted and we need to fight on all these different fronts?
Right now, it looks like it's multifaceted, but it's interconnected. So if you fix one thing, you are going to help other hallmarks. For example, if we have mitochondria in each of our cells, they provide energy from sugar. As you eat, they take the sugar and give you energy. In each cell, there are maybe tens or hundreds or even up to 1,000 mitochondria, depending on the cell type. And there are fewer of them. They get corrupted as you age, and so you don't have that energy to run your body. You say if you can fix mitochondria, that's expected to fix other hallmarks. It will help your metabolism, and it will help your immune system. Mitochondria is in every cell, and blood cells, brain cells, everywhere. So that's one that is a central one, if you will, but it will not fix everything. I mean, the immune system is enormously complex, and it grows weaker with age. And we've all witnessed during COVID who was dying in hospitals. It was mostly older people. And why? That's because of the immune system. And the immune system, it doesn't just get weaker, it goes nuts. It attacks your body, the cell. There are autoimmune issues that happen with age. Super complex. So it isn't just a question of, okay, let's fix the power in all the immune cells. It's not, you're going to have to look at, T cells and B cells and all, what really goes wrong. The devil's in the detail, right? You have other hallmarks. You have stem cell exhaustion. That's one of the hallmarks. We have stem cells. We have a lot of them when we're young. What do? As our cells have finite life, they divide and divide, and then they stop dividing. That's normal. But to replace the cell, stem cell would then come in and divide into this one cell and itself. So the stem cells supposedly propagate themselves throughout life, but that's not a perfect process. They get corrupted. So as you get older, you have exhaustion of stem cells. You don't have enough of them. They don't work well. We're now finding that not only is there exhaustion, but the ones you have will actually work well if you put them in a younger body. They will work just like young stem cells. Why? And now there's suspicion that it's the extracellular matrix. They need that matrix or something in the young body. We may not know the whole story yet. Uh, and so, yeah, so people are using stem cells now, but I think they need more than just stem cells. They need to fix the structure, the collagen and elastin. So no, I don't think it's any one thing, but I think that you can get started with one powerful thing and feel a whole lot better and last longer. But we need this. This is an enormously complex problem. We'll be learning for many years to come.
So, the way all these hallmarks of aging are interrelated, it demonstrates one of the things that makes biology so extremely complicated is that it's this incredible interplay, right, of trillions of cells, all of these reactions within each of the cells. Everything is so highly contextual, right? Even DNA doesn't really code for a human being, right? It codes for a human being when in the context of all the right enzymes and everything else. Stem cells need to be in the right extracellular matrix. It's such a complex system. Do you think, we've obviously been able to make strides. We can, treat diseases, all sorts of things. But to address aging, it seems like we're going to need to understand that system at such a deeper level. Do you think we're capable of doing that in sort of the typical theoretical way we do science? Or do you think it's so complex we basically just need to hope AI can explain it to
Yeah,
us?
I mean, that excellent question. All of the above. Okay, AI and humans work well together. AI is a powerful force. We are all going to be relying on it. For example, what can AI do? If I'm trying to solve a problem, let's pick up on stem cells again. I want to learn about stem cells and extracellular matrix. I can take ChatGPT. I can outline, say, 1,000 papers on this, or I can ask it, go find all the papers on the subject. Say there are 1,000. A human being cannot process those papers in any efficient way. It would take years to read them. So I can tell ChatGPT, go read these papers, and here's a dozen questions. Get me the answer from these papers and summarize with references the answers. So that's a very powerful tool. But as a human being, I need to know how to drive this tool, what information it needs. It needs a knowledge base to work well, and what questions I'm trying to answer. And then, once it gives me my answers, I could engage the scientists who specialize in these fields. And to your point, is, I mean, many different specialists will be needed. Immunologists, immune system is the most complex beast. You need hematologists, you need geneticists, because there's genetic information lost, but it can be recovered. It turns out we have an extra copy. We can fix genetic errors that happen with age. There's a ton of expertise, and you need the depth and the breadth. And the good news is, it's not the scientists that are going to be the limiting factor here. We have amazing, brilliant minds who just want to do this work. And we could be moving fast, right? And with AI, I mean, that's like getting a rocket ship to propel us, right? We can go exponentially. Another thing I'm going to throw in exponentially is that as we live longer, there is an exponential thing going on, because we get exponentially smarter, because with every year of life, you have seen more, you've interacted with more people, you've got experience to become more productive, more creative, more resourceful. And that goes exponentially. And I feel it, right? But what I'm scared of is that as you age, all the deterioration with age, then it takes everything away from us, right? And we start declining. But if we start figuring out how not to decline, we just keep going. And so, the humans get exponentially smarter. AI, because it's our own tool, it's our own creation. It gets better. We learn to drive it better. We learn more and more. Now we're healthier. So things are going to be exponential. It's super exciting.
You mentioned that you don't think the science or like the scientists are holding us back. Does that mean you think sort of we're doing enough of the fundamental research? The bottleneck is more in sort of our ability to go and test these things in humans to build them into real products. Sort of like, where is that limiting factor in our fight for longevity?
Yeah, it's in testing in real people, right? Um, it's a stodgy industry, saddled with regulations. So to give you an example, difference between high tech, as an engineer, I was able with my last company, and I had enough experience, and I was able to get into my basement with two co-founders, the three of us. Uh, Created a product, and we were selling and making revenue in a year, right? It was on the market. How can we do that in biology? We cannot do that because we're not allowed. There's all these regulations. It takes $1 billion in 10 years. $1 billion in 10 years to get a drug to market or into humans, right? Or into humans, it may take 5 years, right? Or 6 years, it depends. But it's so expensive, it is much, much harder for the companies. I mean, the expense is the regulations. Now, everybody obviously is afraid of venture, uh, killing people. If you give somebody an untested drug, what's going to happen? And so we have regulations to protect us from new drugs and their effects, and from snake oil salesmen who can do damage. But there's a overreaction and overprotection to the point of ridiculousness, to the point of this 10 years, and the $1 billion versus how we did it in a year on some consulting revenue that the three of us earned on the side, right? And I don't know where the right answer is to enable this industry. And there are other uh, legislative areas that are opening up where you can more freely, uh, say, do a study with humans, willing humans who may be dying and need something desperately, and understand the risks, right? We're all free agents. So anyway, so that is what's holding us back.
And is there something in particular that you would recommend changing? Is it basically I think the FDA has basically thresholds for statistical significance they have defined based off of how I guess important the drug is, right? If you're treating a highly lethal disease, they would need a lower N count, a lower threshold to approve it based on clinical trials. Would you boil it down to something like that, which is that they don't think of aging as a disease currently, and so the threshold is just too high to test these types of drugs? They need to basically allow a little bit more risk to push forward here.
Right. Well, they don't think of aging as a disease, but the companies we invest in, they can easily find the disease. I don't think that's what's stopping us. Because if you can fix the hallmarks, you can do two things right off the bat. You can rejuvenate a person, and you can cure any number of diseases that relate to that hallmark you fit, right? There's more than one disease. And they pick the disease that's easiest to get through the FDA. It could be an orphan disease. And then they get to market, but they can treat multiple diseases. That's the power of this industry, is if you understand the root cause. I mean, there are hundreds of diseases and a dozen hallmarks, give or take. Okay. So if you really can keep someone young, is there any doubt they're not going to get diseases? For all practical purposes, there's no doubt. We know about it. We've known about aging causing diseases for a long time. So I don't think it's a problem to find a disease. What the problem is the fundamental uh, chokehold, this regulatory chokehold. This $1 billion is a problem. 10 years is a problem, right? No matter how you do it, you find an orphan disease, maybe it's not 10 years, maybe it's 5 years. It's still years. It's not, nothing's easy. So yeah, we need to get back to the age where scientists just tried their own cures, their own products, and showed to the world, and then we were free to go experiment. Now, if you say at this point, you can't just go back all the way, but you could say, okay, let's prove safety. Something is safe. I don't know if it's efficacious, right? But it's safe. And maybe it's the government that tells me safe, or maybe it's an independent lab like Consumer Reports, like some independent entity we trust. And then, but they don't know what it's going to do for aging. And um, it's up to me to decide if I want to trust it or not. And I will read all about it, and I could say, okay, I'll take a chance. I'll go do it. And if millions of people go and try something promising, that's a trial of 1 million people. How quickly can we learn whether it works or not, right? Well, for us to learn, we also need better way of measuring the impact of a treatment. We need much better biomarkers than we have right now. We need biomarkers these millions of people have access to in their homes, and they're easy to use and report on. We need AI, to your earlier question, to collect and process all this data, because there'll be massive amount of data. We're just not equipped to run such big trials today, but that's the paradigm shift that I see could make a big difference, and we'll learn really fast.
The paradigm shift being more and more data on people's personal health.
Open trials, massive open trials. And as a result of that data, it'll be oceans of data.
I see. As in people being allowed to experiment with something, if they think it's safe. For example, metformin is used to treat diabetes, right? But we have a lot of people taking it as a longevity supplement already. If we were able to consolidate, or if people could share the data from their own personal experience with metformin and tons of data, biomarkers, vitals, like whatever, that is sort of the paradigm that would allow us to make more progress here.
Yes, exactly.
And so, I mean, it seems like the biomarkers of aging is incredibly important, because it's one of the ways we would be able to, well, in a certain sense, it's like identifying the root cause of aging, right? Or if you identify a biomarker of aging, you've identified something tied to whatever causal pathways of aging. For that reason, do you think, biomarkers or diagnostics more broadly, do you think that is the area that will have the biggest impact in longevity right now? Or do you think it's more important to invest into, the actual therapies, devices, and so on?
You need it all, because how do you know your therapies are working without the biomarkers, right? So biomarkers happen to be my pet peeve, right? And why is it my pet peeve? Is because I come from the test and measurement industry. In my past life, my focus was data communications and measuring the performance. And it's a very similar to measuring what's going on in your body, because it's a very noisy signal, right? Your biomarkers, your state of health will change if you don't get enough sleep, you have the flu, some it depends on your health, they will fluctuate, right? So some people say, oh, I had this stem cell treatment and it rejuvenated me by 6 years. And I, as a test and measurement professional, say, well, I know the test you use, there's this a biological age test, is either methylation or whatever they use. Proteomics is a new one that could be powerful. But then, how do you know you didn't measure it at the peak before your treatment and at the trough after your treatment? And that's what you're measuring. You're measuring noise. You don't know that. But the industry doesn't have an easy enough and inexpensive enough way to measure these things, that you can do it multiple times. So you have enough samples, if you will, the Nyquist frequency of this information you're trying to extract. And you can then apply the known signal processing techniques and extract the actual signal from the fluid. You need some inexpensive, reliable metrics. Now we know what to measure. It's not that we don't know and we need something new. There's blood work, there are indications of how healthy you are. And age and health go together in my mind. When you measure biological age, you basically measure your state of health. I mean, even from blood work, like you said, vital signs, some physical tests you can do, what your state of health is, what your age is. But then there are modern tests like methylation, like proteomics, metabolomics. There are a lot of tests you can do. But it's not that we don't have tests, it's just that we cannot run them economically and at home. And so we end up measuring this noisy signal and undersampling it. And that's a big problem because we really truly don't know what these therapies are doing. We don't have a good way. And the doctors will send you for all these tests, and you can spend $10,000 a year on tests. But I don't trust them. I've done a few of them and I can see the fluctuations. I read about fluctuations and I'm like, what good is this test for me? I need to be able to do it daily or weekly or whatever to really know what's going on. Right. Or I just forget about the tests and watch how I feel. And this is one aspect we need to learn how to do.
I mean, in terms of, figuring out or just getting good data on our health, I've gone down the rabbit hole of nutrition a bunch of times, right? Trying to understand, okay, what should I eat to minimize my risk of heart disease in the long term? And I recently learned about how like ApoB as a blood test is more predictive of, atherosclerosis than LDL is. And so I had to go to the doctor and, I want to test ApoB instead of LDL. And even that was sort of an effort to change what I get tested. And even then, I would normally only get tested once a year. If I want to get tested more often, it's just a challenging thing to do. And, from my perspective, I wonder like, why can't I have in real time some measurement of my ApoB or even some measurement, some view of plaque buildup in my arteries, right? Like this builds up over years, but it's happening moment to moment. So, there's one perspective I always think about, which is if I could just have real time tracking of these things or just more granular data, I could really navigate my lifestyle much more knowledgeably because there's no way I don't think I can feel atherosclerosis. Like, what do you think is holding us back from that? Is there a fundamental science issue still in figuring out the best way to measure these things? Is it a commercial issue of figuring out how to get it to people and how to scale it economically? Or are there huge regulatory barriers in the
No,
way?
there's no actually for testing, it's a lot easier with regulatory barriers, but I think it's just this stodgy thinking that's what everybody expects. And what else are you gonna do? This is a lab test. And I come into this industry and say, guys, this is a noisy signal and you're way under sampling. How do you know anything? Right? I'm with you. I want to watch it in real time. That's what I'm used to, but I can hook up probes to whatever it is I'm measuring and observe it. And that's what I'm used to. I'm spoiled. And it's not that easy in human body. It's not that this isn't necessarily a regulatory barrier. It's that we just haven't done the work and nobody is even thinking that it's a problem because that's what they're all used to. So it takes a person from another industry to come in and say, "Oh my God."
And have you seen any, companies working on this issue? And does the solution take the form of, I don't know, at home, more frequent blood testing, or is it some type of, we have like continuous glucose monitors. Is it a medical device that gives us better testing?
But that's an excellent example. See how much easier it got with just a continuous glucose monitor for diabetics or just people watching their diets, right? Now you have that visibility, and it makes a huge difference. I so I think people are working on it. There are companies that are looking at various proteins. It's just a very hard problem to solve. It's a lot of tests are invasive, right? You can do sugar monitoring with interstitial fluid, so you have this monitor. It's easy to attach, but a lot of the information is actually in your blood, and that either you prick yourself or you have to stick something in to your vein, and it's just not easy. Or you float some nanorobots in your blood. This is now getting uh, to be difficult. It's something we need to be thinking more about. There's a flurry of companies with various sensors through through the skin. It has to be non-invasive in your breath, urine, sweat, you name it. So we'll start figuring this stuff out. I'm working with a small group of scientists and engineers. We're also starting to think about this. Maybe you may be hearing more from us as we develop our ideas.
That's exciting. In thinking, about what it's going to take to bring, those ideas to fruition, is, I imagine there's technological hurdles, right, of figuring out the right way to do it, but there's also, whether there's a demand for this or not. Do you think there is, like, I obviously see the value of these things, and I would spend a lot of money on interesting devices that would measure me, but I don't, people are more interested in, like a Whoop, like basic heart rate monitoring, whatever. Do you think there's a demand for these types of more advanced diagnostics? And I mean, if not, how do we generate more demand for it so that we can invest into this space?
There's demand. I'm sure anybody who pursues longevity is going to want to know what the treatments are doing. All these studies, if we ever turn on these million person studies, we will need an easy way to measure. I think what's going to happen is if it's hard to do, people will be reluctant to do. If you tell someone you have to prick your finger every day and do this, people are just going to get tired of it. It needs to be somehow easy. It's like you almost, if it's something floating inside your bloodstream and recording and all this, and you don't have to think about it, and somehow some central intelligence picks it up into a knowledge base that AI then process, and AI machine learning will figure out and try to understand what these treatments are doing to it. Then you need some human discipline, like you do one thing at a time or you don't know what's doing what to you. It's super complex. But the biomarkers should be easy and automated, or we just won't do them.
So, relatedly, Brian Johnson claims to be, the most tested man alive. He recently hit 1 million subscribers on his YouTube channel, where he's, monitoring his attempt to live forever. What do you think about, his approach? I don't know, the types of testing he does, the therapies he does, but also in general, just what impact he's having on the field.
Yeah, he uses some tests. I think he's using, let's see if I can pronounce it correct, Dunedin clocks. Dunedin clocks, they're epigenetic, ways of measuring the rate of aging. I'm not completely clear on how he measures aging of various organs, but they're proteomic. There's new proteomic science on how to do it, but he isn't really completely open about these metrics. We don't have metrics that the whole world accepts. They're acceptable and repeatable metrics, like in my field. If I measure wireless performance, there are labs that I can use that will give me repeatable measurements. If I send my blood to different labs to measure my biological age, I can get a result that's 10 years apart. That's not good. So maybe relatively speaking, they will tell me how I age if I go always to the same lab. But the methodologies are not standardized. They're not always open. Some lab may do its own thing. And you know, scientists have there is a new effort now, biomarkers of aging consortium between Harvard and Stanford and out of labs. There are a lot of top scientists starting to work on it. And myself and my little group, we're supporting this separately. We are participating and contributing to it. It's going to be a long road before the whole world knows how to measure, and this should be a standards-based thing. We should all be measuring using the same methodologies. Like we have standards for what is a meter, a centimeter, kilogram. If you can believe it, in biology and in medicine, in medicine, more or less, most of the blood work will come out the same within some tolerance in different labs, but not all of it. There are some tests that are completely different. They're not standardized. So, we can start with those. We need to bring them to the home to make them easier. We need to have these newer tests for like organ age. We don't have those established. And how Brian measures them may or may not be valid, and we don't know how he measures them. So he's not completely open. He claims it's, blueprint is an open thing. It's not. A lot of information isn't made open.
When we talk about biomarkers, I mean, all of these concepts, there's so much science that goes into it, right? And your background's in engineering and in high tech, and you've been learning about biology through investing, through your classes. But I think, when we try to learn about these things, there's always this sense that there's so much data, right, that we don't yet know. So, when you're evaluating a target biotech or just thinking about this space, how do you maintain an independent, objective perspective on the underlying technology, on the theories of aging, while also still benefiting from the experts around you?
Yeah, I mean, you cannot always completely de-risk everything at the early stage of research, right? There are still a lot of unknowns, and investing in early stage company carries a risk. So what we go by is, we have a team. We have a very powerful scientific advisory board, with two pioneers in the field, basically people who started the field, Barzilai and Aubrey de Grey. We have other scientists, some CEOs of our companies, entrepreneurs, successful entrepreneurs on this board. So when we are evaluating company, there's usually someone who has the depth, who has deep knowledge in that particular area. And they can tell me, I can go to Diane and say, Diane, what do you think of it? She says, yes, this is a real problem, but the way these guys are approaching it isn't going to work, because she has the depth. She's seen this before. And so we can eliminate sometimes these things. We're not always right. And it's important to remember and not to get arrogant, because investors are often wrong. And we're wrong. We just have to be right more than 50% of the time. It's like batting average. It's not a high number. But if you are right more than 50% of the time, 60%, you can make very good money, right? So not every company you invest in is going to return big. But if you do the diligence, eliminate the obvious ones that are not going to go anywhere, take chances on the good ones, look at the team very carefully. That's the key thing, because you can have people who just, in the scientific world, they just want to publish and go to conferences. Revenue doesn't mean much to them. They grow up in this different environment, right? You need to spot that. You need to have people who are focused on the goal. We want to save the world. We want to cure this disease. We're going to stay in the lab and work on this and get through it. Start doing some practical work with partners. And so this, you need to see how whether they have those skills, whether they understand how important partnerships with big pharma is. It's teamwork. This is hugely complex field, and different scientists have different expertise. So partnerships are key, the breadth of the team and all that. So there are areas, there's certainly a lot of work in evaluating an investment. And we do our best, still knowing what is it that is unknown. We understand that. And like all the good investors, we do our best, and we think we have some companies. The fund has been in existence only a year, but about half of our companies are marked up, and some of them are looking like they may be unicorns. They already have a lot of attention of the industry. So we'll see. It's a long-term game.
And several of the portfolio companies you've invested in already have revenue. We talked about how it takes 10 years, $1 billion to get, to market, at least as a clinical therapeutic. But some of your startups, for example, Matter Bio, their long-term goal is to reverse point mutations in DNA, but they're already generating revenue by detecting point mutations in DNA. Similarly, BioChange has a foam to stimulate tissue regeneration, and they've found a market in veterinary medicine already. Is this something you look for? Business models where there's a path to start generating revenue prior to clinical approval. And is this something that you think is an approach more biotechs should take, given how far off a goal true longevity is?
Yeah, that's an excellent point. That is important because if you have big pharma partners who are paying you, that means you have something valuable they're paying for, right? And so these early partnerships where you get revenue as a company, either from some research services you do that are related to your end goal, because that revenue will also propel you, right? And that's the entrepreneurial thinking, right? How do I start doing something real? If to me, it's always been, if I'm not making money, then I'm not doing anything that matters. If people are paying me, then I'm doing something of value, right? And that still remains a metric, even though in biotech you're more restricted on what you can sell, but there's always some value that you can make revenue with. But you mentioned biochange. We like veterinary companies because there are the regulations are like 10 times lighter, if not less. I mean, there are minimal regulations, and you can learn from our pets. Companion animals live with us. They eat similar food. They're in a similar environment, and they're mammals. And dogs and cats. There is a market. People love their pets, and so there's a market for this. Plus, we are learning a lot, and we can get to market faster. We can start getting revenue. Meanwhile, targeting humans with a longer path through the regulatory channels. But when we have the data, if that's another sign is that it's an entrepreneurial company. They found a way to learn while they have revenue and earn money.
Do you think we'll likely see dramatic life extension of dogs before we see it in humans?
Quite possibly, yes. Yeah, but they're different. They live less. Their lives are much shorter. So clearly, it's different design, right? There's different forces that cause declines. So we're not going to learn all about humans through dogs, but there's some fundamental things we'll learn.
What's the status of, like, the regulatory status of animal testing in the United States? Is it easier to test on dogs in development than it is on humans?
There's still regulatory restrictions, but I mean there are labs like CROs that know all the rules, and they usually biotech companies will go through a CRO, contract research organization, and they would have a terrarium with animals. Typically, mice are the first line of attack. And then you can go to non-human primates like, you know, monkeys, perhaps. That's much more expensive and much highly regulated, so they're longer approvals. As far as dogs, their beagles are kind of the preferred breed uh, for experiments. And I'm not an expert, but it's not a slam dunk, but and there's a cost, and animal studies also take years. And then the problem with animal studies is translation, right? How do you translate that mice? I think there's some very poor statistics, like 70% of research doesn't translate into humans from mice. So, what are we really learning? Do we need better ways of experimenting? Do we need to get to humans faster? We have organoids now, new technology where you can create a little microcosm of an organ, again, brain organoids, just a three-dimensional collection of cells, sometimes with vasculature, and it's alive, and you can test some drugs on it. Organoids are nice because it could be personalized. They can take your stem cells and create little organoids and test drugs on them. So maybe we're moving, that we need some innovation in that space as well.
So I think we're about to be at time. Couple last questions I wanted to ask you. First, how long would you like to live for?
Indefinitely.
I'm always surprised why people don't answer that way. I think most people will give some type of number, and it won't necessarily be that much higher than 90. So yeah. Why did you answer that way?
Well, why should I die if I am able to? I mean, everybody's saying let's square the curve, right? Stay healthy and then die quickly. And I'm like, well, if you're healthy, what's going to make you keel over like that? What happens? Let's figure that out. Because if I'm healthy and I feel good and I'm happy, I want to figure out how to extend that. And yeah, it's going to be, well, we'll see. It's a challenge. We don't know how to do it yet.
And so I'd like to end by asking you, I think, obviously I'm very excited about this space. I think fighting to extend the human health span is one of the, best things that we can do. What's a message if, Tim Ferriss always asks if you could put something on a billboard, what would you put up there? If you could get a message out to everybody with the hope of helping, the longevity industry progress, like what is the message you would want to get out there?
Well, look, I mean, I can only appeal to your personal selfish desire for well being and to thrive and to become exponentially smarter and happier and more productive and more resourceful. Right? I'm not sure how I'm going to put it into billboard, but it's a very strong personal drive that we need to awaken people. And we naturally, healthy people are not self-destructive. We know what's good for us. So yeah, I'll have to think about what to put on the sign, but that's the gist of it.
All right. Thank you so much, Fiona.
Thank you very much for having me. Great questions. Good to see you.